Hello, Internet. So in the last video, I told you that wasm doesn't have GOTO, and I showed you the workaround. Instead of compiling GOTO directly, you compile your function into a state machine and a while loop wrapped around a switch. So the obvious follow-up, I regret not doing it, is where is the code, right? Like, how do you do this transformation going from the AST to the graph and then to the state machine? So today we're going to build it from scratch. And so I've created a mini compiler just to test out this architecture. C0, a very small subset of C, but enough to be able to test out the gotos and the control flow. And it's basically split up into just the 4 parts, right? Today we're going to talk about the AST and the control flow graph. So the AST program is just made up of functions. Functions have a return type of name and parameters and a body. And then we have blocks. We have expressions and statements and control flow. The major ones here, labels for targets of gotos, and then the goto itself, switch statements, and while and break. So that's AST. So the other major data structure here is the control flow graph, or CFG. The control flow graph splits them up into basic blocks. So the outer layer is essentially very similar. You have the module at the top. Modules are made up of functions, and functions also have parameters, return types, names. The interesting bit here is that function bodies are made up of blocks. So like the question is, what is a basic block, right? So basic block is essentially has 3 components. You have the name of the block, you have a list of statements in the block, and then you have a terminator. Essentially, the terminator tells you what happens once the block ends. And the thing about the statements is there can't be any control flow inside a block. Let's look at what a block is in code, and then you set the terminator. But because blocks need to refer to each other, and then you won't have, you can't hook them up right away, you actually, like initially when a block is created, you don't have a terminator, you just add it later. So what are terminators really? So in our simple model, we only really have 4. You can branch, this is unconditional branch, like when you hit the end of a block, you go directly to the beginning of another block and it's fixed. Or you have a branch if, which tests a condition. And if that condition is true, it goes into the beginning of one block. And if it's false, it goes into the beginning of another block. And then we have the return and unreachable statements. In the case of return, you just exit the function, and then if you hit unreachable, then your program crashes, basically. We have these 2 models. We have the AST model, and we have the control flow graph. The question is, like, how do we get from this one to this one, right? And you can do that in a surprisingly not that many lines of code. In C0, this is modeled as a single function. And when we lower the function, so yeah, when we have a function that will take a whole program and turn it into a CFG. Basically, we do that individually. So within each function, we keep track of the current blocks and a current stack of places, so that when you break from the code, you know where to go. When you have operations, which block do you add to? And then when you're ready to terminate, when you've reached the end of a block, how that block is supposed to branch out, right? And then for each statement, we kind of have it's their own thing. The label, case, and blocks, they themselves can actually be the beginning of a new block, so they don't actually require other blocks to be open. The other ones, if there's no block open, it means that the code is dead, right? Like if you have statements after a return, there's just no way you're going to reach those statements, so you just drop them. And here's like just an example of how you would construct it for a while, right? Like, you create multiple blocks related to a while, right? Like when you have a while loop, it's not just one thing. Once the condition is hit, you kind of split as well, right? So you start out at the top of the while loop. And if the condition of the while loop is true, you do some stuff. If it's false, you exit to the end of the while loop. Right? From the point of the control flow graphs, though, it's not so clear that it's a while loop, right? It's just a branching path. Okay, so that's basically it. That was basically it for all the code that, the code that turns an AST into a CFG. But then there's the further question, right? Is actually once you have an AST, once you have so the next question really is, once you have a CFG, how do you turn it into something that you can run? Like something that essentially, right, as we saw in the last video, while and switch statements, the fallback state of a control flow graph, right? There are actually more sophisticated ways of converting a CFG into a format that WebAssembly can process. But at least in my compiler, actually, The easy path is actually just don't even go into a CFG at all. Just emit the AST as is, which is pretty friendly for WebAssembly, except for the gotos. When you do convert into a CFG, one thing you can do is you can actually turn each of these blocks into each segment of the while switch, right? So what does that actually look like in code, right? Literally, we just have a into AST function that does this conversion. And again, similarly, we just go back the other way. Instead of lowering into a CFG function, we lift a CFG function into an AST function. Okay. And yeah, and then as our first helper, we actually lift one block at a time, right? And when you lift a block, because of the way we've designed our CFG, we can basically copy over the statements. In a slightly more sophisticated, so in a more sophisticated CFG, you would do some sort of translation of like the 3 address, like you would have a little bit more sophisticated way of converting the instructions to a friendly format. So in our case, it's quite simple. And then depending on what the terminator is, we can branch out and decide to do something different. So for example, like if you see an unconditional branching into a different basic block, you just set the state to be the ID of that basic block and then just break, right? If you have something like a situation where you're branching, like in what if it's true, you go one block. You literally just have an if statement where you say, if the condition is true, you set the state to this. If it's not, you set the state to this. And then once you have all of these segments with the cases and all the state jumps, you can shove them all into a single switch statement, right? And then wrap that switch statement into a while statement so that whenever like a block needs to move somewhere, the state is updated, and then you come back up to the top of the loop.